Good morning, everyone. Welcome to ISHP 2024 workshop. My name is Lirong Wei, and I'm a senior data analyst and researcher of AHP. And in this workshop, I will introduce you to the latest version of the AHP-AhpAnpLib. And if back at ISHP 2022, if you were in one of the workshops, Alina Roku introduced the library. And since then, there are a lot of great updates. So today, we will go through the latest version of AhpAnpLib. We will go through the process how to use it for AHP models. So let's get started. First of all, let's take an overview of what will be covered today. And so first of all, we will set up the environment, and we will use Google Colab, which is a cloud-based environment. It already has Python and all the basic library installed. So you will see it will save us a lot of time, and it is a big change that's moving to the new version. And then we will structure an AHP model in Excel. And this is one of the big change in the new version as well. You will see we can structure the model inside Excel, which we can totally focus on the model. Don't need to worry about what commands, what code we use. And we just format it in a way that the library can understand. And then we will import it into Python. So I've prepared an AHP model in advance, but if you feel comfortable, if you prefer, you can use one of your own models, but I recommend you use a very simple one. And after importing to Python, then we can generate questionnaires from there, and then do the calculations using the filled-in questionnaire. And at the end, we'll conduct a basic sensitivity analysis using library. If time allows, I will show you how to repurpose SuperDecisions model in Python. I don't know how many of SuperDecision users are here today, but you will be really happy to see it. It's a very powerful function in this version. And at the end of this workshop, you will have an environment with you that you can use anytime in the future to help you with AHP models. And yeah, you will know how to use the library to do the AHP model. So that's our goal. And please feel free to put any comments, questions, or suggestions in the chat, and we'll get to the questions and answers section at the end. And before we get to the environment setup, I do want to briefly introduce the library. So just in case it's the first time you hear about the library name is AhpAnpLib. It is a Python library, and it's developed by Creative Decisions Foundation to assist the process of structuring models. So, Alina wrote the code, and it's been maintained on this PyPy.org, and you can always find the latest and the greatest version for free there. And it can be used for AHP model, AMP model. It can be used for pairwise comparisons or readings, and also BOCR models. And later today, Anna is giving another workshop. It's using the libraries more on advanced topics. So if you're interested, be sure to join in. So let's start our environment. So as we said, we use Google Colab as our environment. So there's really nothing need to be installed locally. All we have to do is to open your browser, any browser, and then we'll go to colab.research.google.com. Okay. I'll put this in the chat. All right. So I do recommend logging to your Google account when we're on the Colab, just so you get a lot more great features that Google provides. And so give it a second to log in. And when you log in, we'll be on this interface and just click New Notebook. So what we did is that we just created a new Jupyter notebook and automatically opened it in Google Colab. So let's take a moment just to get familiar with this interface. So on the left top, we'll see the file name, and just click on it. We can change the file name. I'll change it to AHP workshop, and click anywhere else. It will be saved. And then you will see we have menus here, and we have two important buttons, one to add a code cell and one to add text. Just we use Jupyter Notebook. In anywhere else, we can have code and the text at the same time. And just we can execute the code here and to see the results immediately. And we can also add titles and descriptions to get it organized. And if we don't need this cell, we can just use this delete button on this float menu next to the cell there. Delete this. I'll just leave one here. And we have a connect button here. When connect to it, it's connecting to this temporary server that Google provides. And we'll see it gave us pretty good resource, and it is for free. So I'm using the free version. So it's totally okay. And so the first thing we will need to do is to install our library. To do that, in the first code cell, we'll put examination mark, pep, install AHP AhpAnpLib. And then we'll click this execute button right next to it. Now it's collecting all the, let me put it in the chat. So it's collecting all the different libraries and installing it automatically. Once it's successfully finished, we'll see this is a check mark. So in 5 seconds, we have the library installed. So let me head the output just to make it easier to see. So as we installed, next thing we'll do is to import the library. So there are several modules in the library we usually use. So the first one we use is the structuring, how to structure the model, like creating nodes, clusters, and the model. So we will do from AhpAnpLib import struct. See, as I tap in there, it gives out a hint of the what name should be. Just click on it, it will auto-complete. This is one of the great features that Google Colab provides. So give it a short name. I'll give it a short name as struct, and then we'll import the second one. The second one is inputs. So it will handle file input and output, like Excel files and text files. So we will import inputs to the auto completion as, give it a short name, input. Okay. And then last one we will use in the AHP model is calculations. So as the name size, we will use this module to do calculation. So it calculates AhpLib as calc. So I'll put this in chat as well. Execute. Nice and clean. See, that means our library installed correctly and imported correctly if you see no message. And so to further validate or test, let's create another code and we will create a model. I'll say it's an AHP workshop. Give it a model name. It's more of a variable name, so no space. And to create a model, we use struct module, and we say struct dot model, and inside it, we can give it one parameter to give a longer, more descriptive name, or you can leave it empty. I'll give it a name, AHP, ISAHP workshop. And I know I have an empty model, but I can still print out the its structure. So to print the structure, we use the model name dot print struct. And I know I have an empty model, but you will see how it is listed. We'll have a model name and tab is pairwise comparison. And once we have node, cluster, and connections, it will all print it out nicely here. Let me send this to chat as well. So that's it. We successfully installed the library, we import the library. So there's one thing different when we run on Google Colab with a cloud-based environment, whereas we run locally is that this is a temporary server or space. We'll always have to run the install first and import every time we open a new conversation. So this file, you only can use it as a template or a header that you use for any model. So as we said, when we create this model, it's automatically create a Jupyter notebook. So we can download this file as Jupyter notebook or Python, then we can use it later, and we always have it locally. Or this file, as we log in Google account before we create the file, so actually create a file under our Google Drive. So we can go to our drive.google.com. In my drive, you will see there is a Colab notebooks folder that's automatically created by Google Colab. And under it, let's sort by last modified by me. You will see this is a file that we just created. So you can also keep it in your Google Drive. You always have it, or download it locally from here. So that's our first section. I think I'll pause a little bit just to see if there's any questions you have. All right, no questions. That's great. So let's continue. Let's back to our presentation here. So we went through the Google Colab. So next we will structure and model in Excel. So I have an AHP model here. I created with the help of our AI friend, and also my friend helped me with this like location or site selection problem. So there is this mid-sized technology consulting company. It's expanding rapidly, and its current lease is ending, so it's looking for a new space. So there are currently 3 alternative locations. It's more of a general ones. At first one, location is downtown in the city center. The second one, location B, suburb. The location C, the third one, industrial park. So based on this problem or this question, we propose this AHP hierarchy model. The goal is, what is the best site for the new office space? And then under the goal, we have decision makers, CEO, operations manager, HR manager, and there are a lot of criteria we need to consider. We'll consider cost, location, infrastructure, employee satisfaction, and we have stakeholders on the first level, employees, clients, and shareholders. And the last level is our alternatives, city center, suburban area, and industrial park. So the connections, we have goal connect to all our decision makers, and all decision makers are connecting to all the criteria. However, the cost will only influence, we assume will only influence shareholders and the clients. The location we assume will influence employees and clients, and infrastructure will influence employees and shareholders. And employee satisfaction clearly will influence all of it. And all the stakeholders are connecting to all the alternatives. So now we'll need to structure this model in Excel file. So I'll show you how to structure it. You can follow me through. If you're also using your model, it's pretty straightforward. So first of all, let's open your Excel. Let me go to my desktop. Here's my Excel. Let me save it first. I'll save it as, save it to a place. I'll save it to my desktop, site selection, save. And So first of all, we will put all our clusters and nodes inside each cluster in it. So we'll start from A1 and we will put all the clusters with cluster name on the first column. You can have space, it will be the name. So it's okay to put space in. So we will follow the structure. We'll say go, decision makers, criteria, stakeholders, and alternatives. All right, so that's all our clusters. That's all my clusters actually. And then follow each cluster name. We'll put a node name right next to the cluster. Don't leave any space if you have multiple nodes in this cluster. Just put it one by one closely. So for the goal, we have best new set. For the decision maker, we have CEO, operations manager, HR manager. And then for the criteria, we have cost, location. Just let me know if you can see my screen clearly. Sorry, I just want to follow this structure to make sure I have the same name. Employee, satisfaction. And then we have stakeholders. We have, let me make this smaller. So we have employees, clients, shareholders, and alternatives. We have city center, suburban area, industrial park. All right, so we put all the clusters and the nodes here. So this is our first sheet, which represent our structure. And the next piece, we will need to put the connections in Excel as well. To do that, we will need to put in a separate sheet. So you can keep the sheet name as sheet 1, but you can also change the name. This name will be referenced when we import the Excel. So we need to remember the name. I'll make it as structure. In the second sheet, we will put the connections. I'll call it the connections. And so to do the connections, we will use more like connection matrix. So we put all the nodes on the first line and also on the first column. So we form a matrix, and let's do that first. So you see I'm doing the copy and the paste here because we need the name. We need the name to be exactly saying the space, the case. So I just like to copy and paste here. It's easy. It's really easy for me to make mistakes if I type it in twice. So I'll do all the copy and the paste, and copy all the nodes on the first line, and make it bigger. So all my nodes are here. So this will be our from node, and let's copy it and paste. We will copy it again, and when we paste, copy it, copy, and when we paste, we'll do a transpose paste. So now we have a matrix. We'll take all the nodes top as from node, like from best new set, the goal, we connect to all the decision makers. I'll put a 1, 1, 1 here. And from the decision makers, each decision maker connecting to all the criteria, I'll put a 1, 1, 1 here. So let me it's the same connection for all the decision makers. So I'll copy it, and cost will only influence client and shareholders. And we have locations connecting to employees and the clients, and infrastructure, employees and shareholders, employee satisfaction, influence all of it, and all our stakeholders connecting to all the alternatives. Let's do this. And there's no connection from alternatives. That's a bottom level. So let's save this file again, save it, and close it. So we have our model in the Excel file. Next step, we will import into Python. So unfortunately, the Google Colab has no direct access to our local files, but it provides two ways that we can use this file. Since we just created locally, there are two ways to use it. Let's go back to our Google Colab. Did I close it? Okay, I was using Chrome. So yeah. So there are two ways. First of all, we can use Google Drive. Then we can mount Google Drive and import it into Google Colab. There is another way. Since we're on this server, it provides temporary space that we can use temporarily. So we can temporarily upload the files to here. So to do that, just click on this files icon, and there's an upload. So I'll show this method first, but I have another method that how to use a Google Drive inside my PowerPoint that you can use. And I'll also show you how to use it in another example. So let's use the temporary server space here. It's just more straightforward. So let's upload the file. So I put it on my desktop. It's here. So it's give you this warning just to remind you that the files is just temporary here. Once this session is finished, it'll be deleted. So say okay, see the file is here. Now we can reference it. So to import the file, we'll create a new code. So as we said, we use the input module to deal with the input and output. So to import an Excel file, we'll do input rate model input dot rate structs from Excel. So we will need to rate or import the structure, the nodes class first before we can import the connections. So for this rate struct from Excel, as we hover on it, after we put the parentheses, it gives you the hint of what parameters we need to use. So first parameter is the model name, not the long one, but the one with the variable name and the file path. Since we're on the server, so we can directly put it the file name here, that selection.xx. But if you're using Google Drive, you will see you need to put the path here based on where you which folder you saved the file. And sheet name, so our structure is inside the structure, if I remember correctly, and then verbal. So whether we want to put out the details when we import it. So I'll put it as false. It's pretty useful if we encounter any problem. We can say true. It's pretty useful for our debug, but I'll put it as false first. And execute, seeing important. And then we will import. Sorry, I forgot to put it in the chat. Let me put it in the chat. And then in the new code cell, or you can put in the same one, read connection from Excel. We will do AHP workshop, same file, set selection that sets connection true and execute. Okay, so it gives our name. So I think it's connections. So see, when we say true, it print out all those details. So let's hide it for now. Hide the output. So now I have the model. Let's print the model structure again to validate it's imported all correctly. And to do that, we will do AHP workshop.print struct execute. We will see we got all the nodes here, all the clusters, and the node collections. Now we have the model inside Python. Let's hide the structure for now so we can see clearly. And next, we will do another code. So now we have the model inside Python. We can really do generate an Excel for the model, right? So to do that, we'll do input the export Excel questionnaire full, and the first parameter we will put it be workshop, and the file path will be the file name that we put out. And we will say questionnaire, it should be Excel file extension, and whether we want to show estimates. So we'll have an estimation column inside the questionnaire Excel. I'll show you when we export. So we'll say true, so it will be visible there, and the verbal, whether we want to output the export details. So put it as false first and execute. Wait one moment, you will see the questionnaire empty generated here. And click on the three dots, you can download it. Now we have this questionnaire locally. As we said, we included the estimation column. You will see we have all the pairwise comparison matrix, and we have this estimated priority. And as we input the values here, and the estimated priorities will be updated, so you can validate your thinking process. So this is a questionnaire you can really send out to experts for your model. So we'll do it here. I'll show you how to put in. It's really the pairwise comparison matrix we usually use. In HP model, we use 1 to 9 scales to fill in the pairwise comparisons, or we can also use direct values. But when we put direct values, all the pairwise comparison values will be ignored. And so to have your judgment, let's save the file first. We'll say filled in. So I already have one. Let's cancel. Let's put it on my desktop. Save. So to fill in the pairwise comparison matrix, like we'll say, respect to best new set, CEO, and operations manager. We'll see they are equally important. So I'll say 1, and CEO is much more important than HR. So I'll say 5. And similarly, operations manager is 5. So you will see we have the estimated priority here, and this estimate is inconsistency. 100% consistent, so it's 0 here. And there's one thing that I need to note that inside Excel, we put the fractions. I'll say cost as with respect to CEO, maybe location is moderately more important. then cost. So I need to put 1/3. So instead of 1/3, I need to put equal sign first, then 1/3. Then it will do the correct value for me. This, for example, if I do say infrastructure is more important than cost, if I just directly put 1/5, it will automatically convert to a date format. So to do that, we need to go change it back to number and then put as 1/5 again. Now it can correct. So just to make sure when you do the fractions, put in the equal sign first. And you can also use direct values and make sure if it's like a cost or something that you need to, like which cost more should be less preferred. You want to revert the values before putting the direct values. So I don't want to waste all our time to fill in this questionnaire. So I have one already filled in advance. Let me bring up that. I have filled in here. So now I will use this filled in to import back to my Python model so I can do all the calculations. Let's close it. Similarly, we can upload the file to this temporary space. So it's now here. We can use it to do the calculations. Oh, so let me send this to the chat. So maybe before I jump to the calculations, there's any questions. Okay, yeah, let's go to the calculations. Code, another code cell, to do the calculations, what we'll do, CALC, calculate. We'll do calculate AHP matrices saved to file. Click on that one. And to do that, first of all, we will put model name as our first parameter, AHP workshop, input file name. So what is a filled-in file we will need to use? So we will do questionnaire filled in that. And then the third one, what is a file name we will use as a results file, or just to say results as. And then we will use as true input because we want to use our filled-in questionnaire to calculate the results. And the normal bar, whether we want to put a bar in the normal priorities, I'll say false, but I don't want to put a bar for the ideal values. So I will say true here. And verbal, I'll say false. I don't want to export all the details now. So execute. Now we'll see we have results file here, and we can download it to check out the results. See, this results file is a very comprehensive one. It got all the pairwise comparisons, the results of all the priority vectors, with normal priorities and your priorities and inconsistency. So that will help you to improve the results. And we have some other tabs or sheets. The second one, we have a nice picture of our hierarchy model. And the third one, supermatrix, then limit matrix, limiting priorities. And the last one has our final results. So you see, as my input, I put employees on a very high priority. And at the end, city center will be preferred. So that is just my results. You can find your results in the local priorities, which is our final results here. And then you can take from here to do all your analysis. And okay, let's save it. Any questions so far? Okay, good. So let's go go to the last one. We want to do a basic sensitive analysis. To do that, we'll create a new code. We'll do the calculate AHP, calculate sensitivity cell super matrix plot. So we use sensitivity cell super matrix plot. And for the parentheses, we'll see all, overall, we'll see all the parameters we need. First of all, name, and then cluster name. What is class alternatives? So now for the AHP, we can only put alternatives as a cluster name. But of course, if your alternatives is not, it's not alternatives, it's more like alternative, you need to put alternative here. So that's your alternatives cluster name. And then we'll do, let's see, what's the third parameter? So the file, we want to put the results. So we can give the same file that put all the pairwise comparison results and the final results, or give the new file name. I just like to put all them together, so I have all the results together. So I'll put the same file name. It will append new sheets there. Verbal or say false. And now we need to put all the criteria or the other nodes that we're interested, how they change or influence the results, the priority of the alternatives here. So I'm interested in cost, actually, employees, and which is one of the clusters, is one of the stakeholders, and employee satisfaction. And you can put a lot more if you're interested. I'll just put 3 here for now. Let's execute. We can see the results. 1 second. Let's see. It complains something. We should be multiplier. So it gives me the cost. We'll see. Our cost was very low, has a very low priority, but as it's becoming more important, then there's turn points that the industry park and will become better, or will become, there is a turn part here. After this point, the industry park would be the best choice. And we'll see employees. So there's no employee satisfaction. I think I misspelled it. That's why it gives me error. So let's do it again. Okay, now we'll see employee satisfaction will not influence much of the results. And then we can also download the results. We'll see the results also inside our Excel file. Let's download it again. Download. So after the local priorities tab, you will see each tab for each sensitivity analysis. So that's all we want to cover for this AHP model. So really, you can take this file as a template. Every time you just need to change the file name or the model name, and then you can use it for each model. It's more or less the same. And before we jump to the end of the questions, let's review what we did. So first of all, we installed the AhpAnpLib, then we imported the library, then we created the model, and we created the model structure inside Excel file, which is outside the library. So we focus on the model, and then we imported the model into Python, and so we exported the questionnaire from there to collect the judgment inside a fielding questionnaire. We bring in the field questionnaire to do the calculations. And at the end, we performed sensitive analysis. And since we still have several minutes, I think, So I'll show you one more thing. This is all the code. So I'll show you one more thing, how to import SuperDecisions model and repurpose it into Python model. So I already have, if you have that folder I shared at the beginning, let's go back to the folder, and you will see there is a SuperDecisions to Python. So take that file and open it. So you will see every time we will need to install the library and import it at the beginning. And to repurpose the SuperDecisions model, we need the SuperDecisions model on the server or in the Google Colab as well. So the Jupyter Notebook can get access to it. So in this file, I show you how to use the Google Colab. So let's first, so to use Google Colab, I use the from Google.colab import drive, and then we mount the drive to a place, usually content drive, and we can force it to remount every time. And then let's execute it. And let me execute till here. Runtime, run before. Now it's installing. And import. So I'll give the model name as this is a set selection. I have the same model as SuperDecisions. You can have any SuperDecisions model here. You just give a model name that we use in Python, and it would all the generated Python files will have this model name. And so execute, and then I'll mount my Google Drive because I have my SuperDecisions model. When we connect to Google Drive and ask permissions, just click on it and select account and continue. That way it can access. Don't forget last continue. So now it's mount the drive. Okay, so I mounted that account in the drive. So every time when we access the file there, we need to put this account in the drive, pass there, and then will be your drive and the folder name that you put as a file and the file name. So this is the actual one command that will help us to repurpose the SuperDecisions model to Python model. Let me open here. You will see after I execute it, it generates a Python file and also Excel files. So this Python file, it's a more old-styled Python file that created this same model that you have in SuperDecisions, but you have the ability to change all the node names and add connections or added connections, and it already put all the export questionnaire, those calculations there, and all the judgment you have will be exported to the set selection fielding, and your results will be there too. So it's pretty powerful, right? And that's it. So you can really have this file used as one of your converter, and every time you just need to change the model name and the file name here. Probably will switch. It makes more sense to switch. To switch it. Makes more sense. I'll change it later. And yeah, that's it. I hope you like it, and we'll keep using it. And now I'll stop sharing.